This restoration project wasn't carried out in a professional repair shop or a high-end garage filled with expensive equipment. Instead, it was brought to life by a group of young enthusiasts who share the same passion for cars and mechanical engineering. Each member has a different set of skills, from welding and metal fabrication to engine rebuilding and mechanical repair. When they came across an old, abandoned car that had been sitting untouched for years, they decided to take on an ambitious challenge, bringing it back to life. At first glance, most people would probably say the car was only worth its value as scrap metal. The entire body was covered in heavy rust, with many panels eaten through by corrosion. The chassis, suspension, drivetrain components, and especially the engine had all suffered severe damage after years of exposure to the elements. Every bolt was seized with rust, and many parts had practically fused together. Simply taking the vehicle apart required an incredible amount of patience and effort. To speed up the restoration, the team carefully divided the work among themselves. One person focused on repairing the rusted body panels, another rebuilt the engine, while someone else restored the electrical system. In the footage you just watched, one of the team members was working on one of the most important components of the entire vehicle, the rear axle assembly. Many viewers may not know what this component is called because it is normally hidden underneath the vehicle. In reality, the rear axle assembly is one of the most important parts of the drivetrain. It contains numerous gears, shafts, bearings, and the differential, a mechanical invention that is widely considered one of the greatest engineering achievements in automotive history. The first job of the rear axle is to transfer power from the driveshaft to the rear wheels. The engine produces rotational force, but that force cannot be sent directly to the wheels because it must first change direction. Inside the axle housing is a set of bevel gears that redirects the rotation by roughly 90 degrees before delivering power through the axle shafts to the rear wheels. Without this mechanism, the engine would never be able to move the vehicle efficiently. However, what truly makes the rear axle remarkable is the differential hidden inside it. Although relatively compact, this ingenious mechanism plays a vital role whenever the vehicle turns. When a car is traveling in a straight line, both rear wheels rotate at nearly the same speed. But as soon as the vehicle enters a corner, the outside wheel must travel a longer distance than the inside wheel. Naturally, the outside wheel has to rotate faster. If both rear wheels were permanently locked together at the same speed, turning would become extremely difficult. The tires would scrub against the road surface, creating excessive wear, unwanted noise, and reduced stability. The differential solves this problem automatically by allowing the two rear wheels to rotate at different speeds while still delivering power to both of them. This simple yet brilliant design allows the car to corner smoothly, maintain traction, and remain stable throughout the turn. Perhaps the most fascinating part is that this entire process happens through nothing more than precisely engineered mechanical gears. There are no electronic sensors, no computers, and no software controlling the system. Everything works purely because the gears are carefully designed and perfectly positioned. It is a remarkable example of how brilliant engineering can solve complex problems using elegant mechanical principles alone. After spending years abandoned, the rear axle on this vehicle was completely covered in rust, dirt, and hardened grease. Every component had to be disassembled, thoroughly cleaned, inspected for wear, and measured to determine whether it could be reused. Worn bearings and seals were replaced, the gears were carefully examined for damage, and the entire housing was refinished before everything was reassembled with precise adjustments. This stage demands exceptional patience and accuracy because even the slightest mistake during assembly can lead to excessive noise, vibration, or premature wear once the vehicle is back on the road. Watching these heavily rusted components gradually return to perfect working condition is a reminder of just how much engineering is hidden beneath every automobile. Behind what most people see as an ordinary car lies a collection of incredibly sophisticated mechanical systems working together in perfect harmony. And it is hard not to admire the engineers who designed the rear axle and the differential. Their invention has remained one of the most reliable, durable, and ingenious mechanical systems ever created. Even after more than a century of automotive development, its fundamental design continues to power millions of vehicles around the world every single day. While one team member focused on restoring the rear axle, another equally important stage of the project was already underway. This responsibility was assigned to a different member of the team, the challenging task of removing the engine from the vehicle's body. This is far more than simply lifting a heavy piece of machinery out of the engine bay. The engine is often described as the heart of a car, and for good reason. It is the single most complex mechanical assembly in the entire vehicle, made up of hundreds of precisely engineered components working together in perfect synchronization. Every hose, electrical connector, sensor, mounting bracket, fuel line, cooling pipe, and wiring harness must be disconnected carefully before the engine can even begin to move. Because of this, engine removal is considered one of the most demanding stages of any complete restoration. It requires not only experience and technical knowledge, but also exceptional patience and attention to detail. One careless mistake can damage valuable components or create hours of unnecessary work later in the restoration process. Before touching a single bolt, the team carefully inspected the engine compartment and planned the entire procedure step by step. Every connection had to be identified, photographed, and documented. Instead of rushing through the work, they followed a systematic approach to ensure nothing would be forgotten during reassembly months later. As the disassembly began, every cable, bracket, and accessory was removed in a logical sequence. Although many of these components appear simple, each one plays an important role in the operation of the vehicle. Missing even a small bracket or installing a part in the wrong location can lead to vibration, fluid leaks, electrical problems, or mechanical failures after the restoration is complete. One of the biggest challenges during this stage is organization. An engine contains hundreds of bolts, washers, clips, nuts, and fasteners in different sizes and lengths. To someone unfamiliar with automotive restoration, many of these pieces look almost identical. However, each one is designed for a specific location. That is why experienced restorers never throw hardware into a single container. Every bolt and every small component is carefully sorted, labeled, and stored in separate trays or bags according to the section from which it was removed. This organized approach may seem time-consuming at first, but it saves countless hours during reassembly and dramatically reduces the risk of losing critical parts. Even something as small as a single missing bolt can create unexpected complications. The team might have to spend hours searching through hundreds of parts or even fabricate or source a replacement before work can continue. Sometimes one tiny missing component can delay an entire restoration for days. Years of neglect also introduce another layer of difficulty. Since this car had been abandoned for such a long time, rust had seized many of the bolts and mounting points. Some fasteners refused to loosen despite repeated attempts. Others snapped unexpectedly under pressure because corrosion had weakened the metal over time. These situations are completely normal in restoration work, but they demand experience and quick thinking. Rather than forcing stubborn parts and risking even greater damage, the team constantly adjusted their methods. Heat, penetrating oil, specialized pullers, and carefully selected tools were used whenever necessary to free seized components without damaging surrounding parts. Of course, no restoration project ever goes exactly as planned. Unexpected problems appear almost every day. Hidden corrosion may be discovered beneath components that initially looked solid. Threads may strip unexpectedly. Mounting brackets can crack without warning. Rubber hoses become brittle and fall apart as they are removed. Wiring insulation may crumble after decades of exposure to heat and age. These surprises cannot always be predicted, no matter how carefully the project is planned. What separates experienced restorers from beginners is not avoiding problems altogether, but knowing how to solve them efficiently when they arise. Every member of the team must be able to analyze each situation, adapt quickly, and make sound decisions under pressure. Sometimes they need to repair a damaged component instead of replacing it. Other times, they must redesign a small mounting bracket or fabricate a missing part from scratch. Flexibility, creativity, and problem-solving skills are just as valuable as mechanical knowledge throughout the restoration process. Finally, after countless careful steps, the engine was completely disconnected from the chassis. Suspended securely by the engine hoist, the massive powertrain slowly rose out of the engine bay for the first time in many years. It was a satisfying moment for everyone involved, because this marked the beginning of an entirely new phase of the restoration. With the engine removed, both the powertrain and the empty engine bay could now be restored separately. Every hidden surface that had been impossible to reach before was finally exposed, allowing years of rust, dirt, grease, and corrosion to be cleaned away. At the same time, the engine itself could now be completely dismantled, inspected, rebuilt, and restored piece by piece until it was ready to run like new once again. Although lifting the engine out may appear to be just another step in the restoration, it is actually one of the most critical milestones in the entire project. It demands careful planning, technical expertise, precise organization, and constant teamwork. Every successful restoration is built on thousands of small decisions made correctly, and this stage demonstrates exactly why patience, discipline, and attention to detail are just as important as mechanical skill when bringing a forgotten automobile back to life. With the engine completely disconnected from the chassis, it was finally time for the next crucial stage, lifting it out of the vehicle. Unlike many other components, an automobile engine is extremely heavy. Depending on the model, it can weigh several hundred kilograms, making it impossible to remove safely by hand. Fortunately, the team had prepared for this moment well in advance. Instead of relying on expensive professional equipment, they designed and built their own compact engine hoist. Although it is much smaller than the hydraulic cranes commonly found in commercial repair shops, this homemade lifting machine proved to be remarkably effective. Once securely attached to the engine, the hoist slowly lifted the massive powertrain clear of the engine bay with surprising ease. The entire process was smooth, stable, and well controlled, allowing the team to move the engine away from the vehicle safely without putting anyone at risk or damaging surrounding components. What could have been an exhausting and dangerous task became simple and efficient thanks to this clever piece of equipment. What impressed me the most was not just how well the mini crane performed, but the creativity behind it. Rather than letting limited resources become an obstacle, the team applied their mechanical knowledge and built a practical tool that perfectly suited the job. It is a great example of how thoughtful engineering and problem solving can often accomplish more than expensive machinery. Watching the homemade crane quietly lift such a heavy engine is genuinely satisfying. It reminds us that successful restoration is not only about repairing old vehicles, it is also about innovation, teamwork, and finding smart solutions to difficult challenges. Sometimes the most impressive machine in the workshop is not the car itself, but the tool built by the people determined to bring that car back to life. While the rest of the team continued working on different parts of the vehicle, Another member took on one of the most challenging components of the entire restoration, the transmission. Although it is often hidden beneath the vehicle and rarely attracts much attention, the transmission is one of the most sophisticated mechanical systems ever installed in an automobile. Without it, even the most powerful engine would be unable to deliver its power efficiently to the wheels. In many ways, the transmission serves as the bridge between the engine and the drivetrain, ensuring that power is transferred smoothly under every driving condition. From the outside, a gearbox may look like nothing more than a heavy metal housing. But once it is opened, an incredibly complex mechanical world is revealed. Inside are numerous shafts, precision-cut gears, synchronizers, bearings, selectors, and other carefully engineered components. Every single part has a specific purpose, and together they operate with astonishing precision. The gears inside the transmission are not all the same size. Each gear has a different number of teeth, allowing it to create a unique gear ratio. These different gear ratios determine how much torque and speed are delivered to the wheels. Lower gears provide greater pulling power, making it easier for the vehicle to start moving or climb steep hills. Higher gears reduce engine speed while increasing vehicle speed, improving fuel efficiency and allowing comfortable highway driving. Most people understand that changing gears makes a car go faster or slower. However, very few people have ever seen what actually happens inside the transmission when a gear is selected. The process is surprisingly elegant. As different gears are engaged, power is redirected through various gear combinations, changing the relationship between engine speed and wheel speed. All of this happens through precisely machined metal components working together with incredible accuracy. It is truly fascinating to watch these gears mesh together. Each tooth is manufactured to extremely tight tolerances so that the gears rotate smoothly while minimizing friction, vibration, and wear. Even a tiny manufacturing error could affect the entire operation of the transmission. This level of precision highlights the remarkable engineering that goes into a component most drivers never think about. Restoring a transmission demands just as much patience as restoring an engine, if not more. Every shaft, bearing, synchronizer, and gear must be removed carefully, cleaned thoroughly, and inspected for signs of wear or damage. Years of neglect had left this gearbox covered in rust, hardened grease, and accumulated dirt. Before it could be rebuilt, every single component needed to be restored to the best condition possible. Organization is absolutely essential throughout this process. Many of the gears and internal components appear similar at first glance, but they are designed to fit only one specific location inside the transmission. Installing even one component incorrectly can prevent the gearbox from shifting properly or cause serious mechanical damage once the vehicle is back on the road. For that reason, each part is carefully arranged, labeled, and documented before reassembly begins. As the restoration progressed, the gearbox gradually transformed from a dirty, corroded mechanical assembly into a collection of clean, polished precision components ready for reassembly. Piece by piece, the transmission began to look as though it had just left the factory decades ago. Looking inside a gearbox also gives us a new appreciation for automotive engineering. Although modern vehicles are increasingly controlled by sophisticated electronics and computers, the fundamental principles of the transmission remain rooted in brilliant mechanical design. Without relying on complex software, this system can efficiently multiply torque, adjust speed, and transfer power under countless driving conditions using nothing more than carefully engineered gears and mechanical linkages. It is no exaggeration to say that the transmission ranks among the greatest mechanical inventions in automotive history. It allows a relatively small engine to deliver both tremendous pulling power and comfortable high-speed cruising simply by changing gear ratios. This ingenious invention has transformed the way vehicles perform and remains an essential part of millions of cars around the world. Watching this gearbox being completely disassembled, cleaned, inspected, and rebuilt reminds us that extraordinary engineering is often hidden inside ordinary machines. Most drivers will never see the intricate collection of gears quietly working beneath their vehicle every day. Yet without this remarkable mechanism, modern automobiles would simply not be capable of performing the way they do. It is another perfect example of how human creativity and engineering continue to shape the machines that move our world. This is undoubtedly the most critical stage of the entire restoration project. After successfully rebuilding the transmission, the team finally turned their full attention to the component that determines whether the vehicle will ever run again, the engine itself. For any automobile, the engine is far more than just another mechanical assembly. It is the heart of the machine, responsible for converting fuel into the power that moves the vehicle forward. Every explosion inside the cylinders, every rotation of the crankshaft, and every movement of the pistons must occur with extraordinary precision. If even a single major component fails to operate correctly, the entire engine can lose power or stop functioning altogether. That is why rebuilding an engine is often considered the ultimate challenge in automotive restoration. It demands not only specialized tools and technical knowledge, but also patience, discipline, and an exceptional understanding of how hundreds of individual components work together as one perfectly synchronized system. Before any restoration work could begin, the engine had to be completely dismantled. Every external accessory was removed first, followed by the cylinder head, timing components, oil system, pistons, connecting rods, crankshaft, camshaft, valves, bearings, seals, and countless other internal parts. Piece by piece, the engine was gradually reduced to its smallest individual components. At first glance, this process may seem straightforward. In reality, however, it is one of the most delicate procedures in the entire restoration. Inside an engine are hundreds of precision-machined parts, many of which are manufactured to tolerances measured in only a few thousandths of a millimeter. These tiny clearances allow moving components to rotate smoothly while maintaining the perfect oil film that prevents metal-to-metal contact. Because of these incredibly tight tolerances, every part must be removed with great care. Many components fit together so precisely that they cannot simply be pulled apart by force. Some require specialized pullers, carefully controlled pressure, or a specific sequence of disassembly. Attempting to remove them incorrectly can permanently damage expensive parts that may be impossible to replace. Years of neglect had made the job even more difficult. Rust, hardened oil deposits, carbon buildup, and corrosion had effectively locked many components together. Bolts that had not moved for decades resisted every attempt to loosen them. Some parts appeared almost fused together after years of exposure to moisture and heat. Instead of rushing the process, the team relied on patience and experience. Every stubborn component was approached methodically using the proper tools and techniques. Penetrating oil, gentle heat, precision pullers, and carefully controlled force were used whenever necessary. Their goal was never simply to take the engine apart. It was to preserve every reusable component in the best possible condition. Once disassembled, each individual part was thoroughly cleaned. Layers of grease, carbon deposits, rust, and years of accumulated dirt were carefully removed using specialized cleaning methods. As each component emerged from the cleaning process, its true condition could finally be inspected. Some parts showed almost no wear despite their age, while others required machining, repair, or complete replacement before they could safely return to service. One of the most remarkable things about an engine is the incredible number of moving parts operating together at extremely high speeds. The crankshaft converts the piston's up and down motion into rotary motion. The connecting rods transfer enormous forces with every combustion cycle. The camshaft opens and closes the valves with perfect timing. Bearings support rotating shafts while minimizing friction. Oil passages continuously lubricate every critical surface. Each individual component performs a specific task, yet every one depends on the others for the engine to function correctly. What makes this engineering so extraordinary is that all of these complex movements happen thousands of times every minute while maintaining perfect synchronization. Even the smallest timing error or incorrect clearance can dramatically reduce performance or cause catastrophic engine failure. It is a masterpiece of mechanical engineering where precision is absolutely essential. This is exactly why experienced mechanics never rely on memory alone during an engine rebuild. Every component is carefully organized, labeled, measured, and documented before reassembly. Pistons, connecting rods, bearing caps, valve components, and countless other parts must all return to their original positions unless replacements are being installed. Attention to detail at this stage determines whether the rebuilt engine will run smoothly for years or develop problems shortly after startup. Watching the engine gradually transform from a dirty, seized collection of rusted metal into hundreds of clean, organized precision components is incredibly satisfying. Every clean surface, every polished shaft, and every restored part brings the project one step closer to life again. It is a reminder that even the most neglected machine can be revived when enough knowledge, patience, and determination are applied. For me, this is the true heart of the restoration. It is not simply about repairing an old engine. It is about understanding one of humanity's greatest mechanical achievements. The internal combustion engine is an extraordinary invention, combining hundreds of perfectly engineered parts into a machine capable of producing immense power with remarkable reliability. Seeing every component carefully dismantled, restored, and prepared for reassembly gives us a rare opportunity to appreciate the brilliant engineering hidden beneath every automobile and the remarkable skill required to bring such a complex machine back to life. With every engine component fully disassembled, the team moved on to the next stage of the restoration, one that may appear simple at first glance but is absolutely essential to the success of the entire rebuild. Before any part can be inspected, repaired, or reassembled, it must first be cleaned thoroughly. Years of operation, followed by long-term abandonment, had left every engine component covered with thick layers of grease, burnt oil, carbon deposits, rust, and accumulated dirt. These contaminants not only hide cracks, wear, and other defects, but can also shorten the lifespan of the rebuilt engine if they are not completely removed. For that reason, professional restorers never skip this step, no matter how time-consuming it may be. The cleaning process begins by soaking the parts in a specialized cleaning solvent. This type of solution is designed to dissolve hardened grease, old lubricant, and stubborn deposits that have built up over many years. In some workshops, mechanics may also use clean engine oil or other petroleum-based fluids to soften heavy contamination before the detailed cleaning begins. Allowing the parts to soak gives the solvent time to penetrate every corner, making the next stage much easier. Once the dirt has softened, each component is cleaned by hand using soft brushes of different sizes. Larger brushes are used for broad surfaces, while smaller brushes reach deep into narrow passages, grooves, and tight corners. The goal is not simply to make the parts look clean, but to remove every trace of contamination without scratching or damaging the precision machine surfaces. This stage requires patience more than strength. Every surface must be brushed repeatedly until the grease and carbon deposits are completely removed. Some heavily contaminated parts require several rounds of soaking and brushing before they return to bare metal. Although it is repetitive work, every minute spent cleaning helps ensure a more reliable engine once the restoration is complete. After brushing, each part is carefully wiped with clean cloths to remove the remaining solvent, loosen dirt, and excess oil. As the metal surfaces gradually become visible again, it becomes much easier to inspect the components for cracks, scoring, corrosion, or abnormal wear that may have been hidden beneath years of grime. However, not every engine component can be cleaned with a cloth alone. Precision gears, bearings, oil passages, threaded holes, and other complex mechanical parts contain numerous small spaces that are impossible to reach by hand. If fibers from a cloth become trapped inside these areas, they could later interfere with lubrication or contaminate the rebuilt engine. For these components, the team switches to compressed air. Using an air blowgun, they carefully force high-pressure air through every oil passage, gear tooth, bearing surface, and internal cavity. The powerful airflow removes any remaining solvent, dust, moisture, and tiny particles that might otherwise remain trapped inside the component. It also dries the parts quickly, helping prevent new surface rust from forming before reassembly. Watching compressed air blast away the last traces of dirt is surprisingly satisfying. With each burst of air, dull and dirty metal gradually reveals its original finish. Components that once appeared beyond repair begin to look almost new again, proving that careful restoration is often more about patience than replacing parts. Cleaning also provides an important opportunity for inspection. Once every component is spotless, the mechanics can accurately measure clearances, examine gear teeth, inspect bearing surfaces, and identify even the smallest defects. Tiny cracks, excessive wear, or damaged sealing surfaces become much easier to detect on a perfectly clean part than on one covered with grease and dirt. Although many people focus on the excitement of rebuilding an engine, experienced restorers know that proper cleaning is the foundation of every successful restoration. Even the most expensive new parts cannot perform properly if dirt or metal debris remains inside the engine. A single grain of contamination circulating through the lubrication system can eventually damage bearings, score cylinder walls, or shorten the life of the entire engine. By the time every component has been cleaned, dried, and carefully organized, the transformation is remarkable. What was once a collection of heavily rusted, grease-covered parts has become an orderly set of precision mechanical components ready for inspection and reassembly. It is another reminder that restoring an engine is not about rushing toward the finish line. It is about respecting every small step in the process, because every clean component brings the project one step closer to hearing the engine come back to life once again. After every component had been thoroughly cleaned, inspected, and prepared, the team was finally ready to begin one of the most rewarding stages of the entire restoration, the reassembly process. This is the moment when hundreds of individual parts gradually come together to form a complete engine once again. Although it may appear easier than taking everything apart, experienced mechanics know that reassembly is actually far more demanding. Every step must be performed in the correct order, following the manufacturer's specifications with absolute precision. Unlike disassembly, where there is often more flexibility, rebuilding an engine leaves almost no room for error. Every component has its own designated position, and every installation follows a carefully planned sequence. Some parts must be installed before others because they become inaccessible once additional components are fitted. If even one step is performed out of order, the next component may simply not fit into place. In many cases, the mechanics would have no choice but to disassemble part of the engine again, just to correct a single mistake. For that reason, the team approached this stage with complete focus. There was no rushing, no guessing, and no shortcuts. Every part was picked up only after its installation position had been carefully confirmed. Each bolt, bearing, gasket, seal, and gear was installed exactly where it belonged, ensuring that every moving component would operate as intended once the engine was running again. One of the most fascinating aspects of engine assembly is watching how hundreds of seemingly unrelated parts gradually become one perfectly synchronized machine. Individually, each component appears relatively simple, but when assembled in the correct sequence, they create an incredibly sophisticated mechanism capable of producing enormous power while maintaining remarkable reliability. Precision is everything during this stage. The crankshaft must rotate smoothly within its bearings. The connecting rods must be all in the correct orientation. The pistons must slide freely inside their cylinders with extremely tight clearances. Timing components must be aligned with absolute accuracy so that the valves open and close at precisely the right moment during every combustion cycle. Even the smallest deviation can affect engine performance or, in the worst case, cause catastrophic mechanical failure. The gearbox follows the same principle. Every gear, synchronizer, shaft, and bearing must return to its exact original position. Each gear tooth has been designed to mesh perfectly with its matching gear, allowing power to flow smoothly through the transmission. A single misplaced washer, spacer, or retaining ring could alter the alignment of the entire assembly and prevent the transmission from operating correctly. This is why experienced restorers never rely on memory alone. Every measurement, every tightening sequence, and every torque specification is carefully checked throughout the assembly process. Bolts are tightened gradually in the correct order to distribute force evenly across the engine components. Bearings are lubricated before installation, seals are positioned with great care, and every rotating assembly is tested by hand before the next stage begins. Watching the engine slowly take shape again is incredibly satisfying. Piece by piece, the empty engine block is transformed into a complete power plant. Components that were once scattered across dozens of trays and workbenches gradually return to their proper locations, each one contributing to the operation of the finished engine. What once looked like nothing more than a pile of rusted metal begins to resemble the heart of a living machine once again. Perhaps the most impressive part of this stage is the level of concentration required. There is no room for distraction. Every decision matters, and every small detail contributes to the reliability of the final result. Restoring an engine is not simply about putting parts back together. It is about restoring the precise mechanical relationships that allow every moving component to function in perfect harmony. As the final bolts are tightened and the last major components are installed, the transformation becomes truly remarkable. The engine that was once seized by rust and years of neglect now looks as though it has just been assembled at the factory. Every gear is in its proper place, every rotating component moves freely, and every part has been carefully positioned exactly where it belongs. This stage perfectly demonstrates why engine restoration is considered one of the highest forms of mechanical craftsmanship. Success is not determined by speed, but by precision, patience, and attention to detail. Every correctly installed component brings the project one step closer to its ultimate goal, the While some members of the team concentrated on rebuilding the engine and transmission, the others turned their attention to another equally important task, restoring the vehicle's body. Although it may not involve the same level of mechanical complexity as the drivetrain, body restoration demands an enormous amount of patience, precision, and physical effort. In many ways, it is this stage that determines how the finished vehicle will look when the entire project is complete. The team chose to restore the body using traditional hand tools rather than expensive industrial equipment. Armed with handheld angle grinders fitted with sanding and wire brush discs, they began stripping away the old paint that had covered the vehicle for decades. Years of exposure to sunlight, rain, dust, and moisture had left the original finish badly faded, chipped, and peeling, while rust had spread beneath the paint in many areas. Removing every layer of old paint is far more difficult than it might appear. Large flat panels can be sanded relatively quickly, but a vehicle's body is full of curves, sharp corners, narrow edges, and recessed sections that are much harder to reach. Around the wheel arches, door frames, window openings, and body seams, every centimeter has to be cleaned carefully by hand. These awkward areas require patience and steady hands because rushing the job can damage the metal underneath or leave traces of old paint behind. As the grinders worked across the surface, layer after layer of worn paint disappeared, revealing clean metal underneath. The transformation was gradual, but incredibly satisfying to watch. What had once looked like a neglected, rust-covered shell slowly began to resemble a solid foundation, ready for the next stage of restoration. This part of the project consumed countless hours. The team moved methodically around the entire vehicle, refusing to skip even the smallest section. Every panel received the same level of attention because they understood that the quality of the final paint finish depends almost entirely on the preparation beneath it.